I wish you the best in the exam. Now let's answer these questions as we prepare for the Bece. Now the first question is a straight line. That is question 1A. A straight line passes through the points A with coordinate 5, 10, and the point B with coordinates -13, -14. We have to find I, the gradient of the line, I, the equation of the line which passes through the point, and I, the length of the line joining the points A and B. So let's begin with the first one, then we continue with the next ones. So that's going to be question 1A, I. So let me get it right here, 1A, I. Now, the points that were given are the point A, which has coordinates 5, 10, and the point B, which also has coordinates -13, -14. Now, we have to find the gradient of this. That's very, very simple. When 2 points are given, we ask you to find the gradient. We just have to use the formula, which is this. The gradient of a line is denoted by the letter, small letter m. So that is equal to the change in y over the change in x. And the change in y is the same as, y2 minus y1 out of x2 minus x1. That's the difference between the y and also the x components or coordinates respectively. So that's what we mean by the change in y out of the change in x. So now, how do we get our y2, y1, x2, x1? They are just right here. We just have to label these coordinates so that we know the x1, the x2, the y1, the y2, and what have you. So now, let me label them so that we know these coordinates that we are talking about. So what you have to know is that whenever a point is given, any point given, the first, number that you see is the x coordinates, and the next one is going to be the y coordinates. So when you take this one too, we have x and that of y. So any point that you take, you should know that the two numbers represent the x coordinate and the y coordinate respectively. Now, all these are x. This 5 is x, this one too is x. So that can even create confusion. If I'm to, look for a certain x, you wouldn't know that, 5 that I'm expecting or -13 that I'm expecting. So we just try to give them names so that it avoids that confusion. So we try to give this one, let's say x1, then we name this one another, y1. Here's going to be x2, and here to, y2. So the numbers that we attach to the x and the y are just to label them to avoid any confusion. So now when I say give me, x1, I don't think you're going to give me -13. That is x2. I hope you get, that one. So now we can do the substitutions to find the value of m, which is the gradient of the line that passes through the points. So that's going to be m equal to, so I'm going to do substitutions. So why I say y2, I just have to put in this number. And that's going to be 14, -14 minus y1 is 10. So minus 10 out of, we come to the denominator, which is x2, and x2 is -13 minus x1, which is 5. So that is it. Now we can simplify the numerator to get, -14 minus 10, that's going to be -24. Now out of -13 minus 5, that's going to be -18. So that is what we have. But we can still simplify these two. So what are we going to do? So this negative sign, we just cancel this one. We have 24 out of 18. 6 can go through, the two numbers. So 6 goes here, 4 times, and goes into this one 3 times. So that means the gradient is going to be 4 on 3. So that is what we have. So that's the gradient of this line. So easily, we have been able to find the gradient of the line that passes through the point AB. That is 1A, I. Now let's come to the next one. That's the equation of the line that passes through the points A and B. So that's going to be question 1A, I. That is where we are supposed to find the gradient, the equation of the line, this question. Now, whenever it comes to equation of a straight line, you have to remember the general, equation of a straight line. And that is y equal to mx plus c. So that's the general equation of a straight line. You have to know this, general form. So I'm going to write an equation which must resemble this equation or this form. Y equal to mx plus c. Where y, is a coordinate, the y coordinate on the point, and x is another x coordinate on the point, on the line. M is the gradient of the line, and C is the y-intercept. That is where the line meets the y-axis. So now, how do we get all these coordinates y, x, m, and c? Now, this is what you're supposed to know. The y and the x, they are always going to be like that, y and x. We are not going to use any number for the y and the x. But for the m and the c, there should be a number for that. Unfortunately, we have the m, which is the gradient, to be 4 on 3. So we have to find the c. So that is the y-intercept. And how do we get the y-intercept? That is what we are going to do right now. So let me work that one here. So now we're going to find the c, which is also called the y-intercept. The idea is very, very simple. We're going to look for the value of c. Now, since this is an equation, to find the value of c, we have to know x, we have to know m, we have to know y. For the x and y, we can easily get them from any of these 2 points here. So we have 2 points A and B. I initially told you that any point that you take, the first number is the x, and the next one is the y. So that means that I can use the point A, where my x is going to be 5, and my y is going to be 10. So we can use any of these 2 points, either A or B. If you decide to use B, you can take negative 13 as your x and negative 14 as your y. You can use that one too. Now, for the m, it is 4 on 3. So that means everything is set to find the value of c. So now, I want to take, the point A, which has coordinates 5, 10. So let me write here, taking the point A, which is, 5, 10. So that means there's going to be my x, and here will be my y. So let me do the substitutions here right now. So this implies that y is going to be 10. Remember, I am using this, general equation. Y is equal to 10. So we have 10 equal to m, which is 4 on 3. So we have 4 on 3 here, and times x. X is 5. So we have 5 here, plus c. So this is what we have. Now, we are going to find the value of c using this equation. Now, this is an equation involving fractions. So we have to do away with the fraction by multiplying through by the LCM. So this is a different thing altogether. So now, the LCM is going to be 3. So we just have to multiply 3 by the terms here. So that's going to be 10 times 3 equal to 3 times, 4 times 5 on 3 plus, 3 times c, which is 3c. So let me shake this one up. Now, this 3 will just cancel this 3 here. So we have 10 times 3 is going to be 30. So we have 30 is equal to 4 times 5, which is 20, plus 3c. So how do? We just have to bring this, 20 to this side so that we can find the value of c. So we're going to get 30 minus 20 equal to, 3c. So this is going to be, 10 equal to 3c. You just divide here by 3, here 2 by 3. So this one will cancel this one. So we have c equal to 10 on 3. So that is how we can find the y-intercept, which is, c. Now, don't be drifted away from what we want to achieve. We want to find the equation of the line which passes through the 2 points. Now that we have everything, we can just use this, general form to get our equation. So I'm going to work that one here. So this implies that the equation of the line, remember I'm using y equal to mx plus c. So this is what I'm going to do. I'm going to substitute in the values of m and c. For the y and x, I'll just have to maintain it like that. So that means the equation is going to be y equal to m is already, 4 on 3. So we have 4 on 3 here. X plus c, which we just got to be, 10 on 3. So we have 10 on 3 here. So that's the equation. So that is it. But if we want to, break this one down further, we can just multiply through by the LCM, which is 3. So that's going to be 3y equal to, 3 times 4 on 3x plus 3 times 10 on 3. So you have 3y equal to, this one just cancel this one, also cancel this one. So we have 4x, plus 10. So this is the general equation, the equation of the line. But if you don't mind, you can just, maintain your answer as this one. Y equal to 4 on 3x plus 10 on 3. That's the equation of the line, which passes through the points A and B. So what I want you to know is that you have to know this general form or general equation, y equal to ms plus c. Now look for the gradient, which is m. After that, look for the y-intercept, which is c. You do your substitutions back to get the equation of the straight line. So that is it. Now let's get the next question. That is question 1a I. This question. So we have 1a I. The question numbers are always very, very important. And the question is saying that we should find the length of the line joining A and B. This is a formula work. To get the length of the line joining A and B, remember that the coordinates of the points A are, so let me just rewrite them again, 5, 10, and that of B, we have -13, -14. So these are the, the coordinates of the respective points. Now, the magnitude or the length of the line joining A and B is going to be like this. So you can just say the magnitude, that is a simple way to write magnitude. The magnitude of A and B, which is the same as the length of the line joining A and B, is equal to this. So that's going to be the root of this. We have to know this formula. So we have x2 minus x1 all squared plus y2 minus y1 all squared. So this is the formula that we are going to use. You have to remember this formula. That's the formula that we use to find the length of the line joining, 2 points. So now let's do our substitutions, simplify, then we get our final answer. So now x2, we know that this is x1, y1, x2, y2. So x2 is going to be, minus 13. So we have -13 minus x1, which is 5. Now all squared plus y2, which is -14 minus y1, which is 10. Remember to square it according to the formula. So now we're going to get, the root of -13 minus 5 is going to be -18. So we have -18 all squared plus, this is also going to be -24 all squared. So that is what we have. So -18 all squared means 18 times -18. That will give me 324. We can multiply, and this one too, -24 times -24, that will give me 576. So these are the numbers that I'm going to get. Now I have to simplify further by adding these two guys. So that will give me 900. So we have the root of 900. And what's the root of 900? That is interesting. You see, this is a perfect square. So the root of 900 is going to be, 30. So you have 30 units. So that's the length of the line joining the points A and B. Very, very simple. So you just have to know this formula, and that is all. You do your substitutions, simplify, you get a final answer. Now let's come to, the last two for the question 1A. So let's get our last but one for the, 1AI. So that's going to be 1AI IV. That is IV. So we have to find the x-intercept. Oh, that's very, very interesting. Now, to get the x-intercept, you have to know the meaning of the x-intercept. The x-intercept is, where the line meets the s-axis. So, assuming this is straight, the OY plane. And now, this is the straight line. Just an assumption. So, assuming this straight line, this point that we see here, where I'm trying to shade, this point, is what we call the x-intercept, because that is where the line meets the s-axis. Now you should know that on the x-intercept, where the line meets the s-axis, the y-coordinate is going to be 0. So any point here, any point on the s-axis, y-axis is going to be 0. So that's what you're supposed to know. So I'm going to use this idea here to find the x-intercept here. So let me clear this stuff from here. Good. So now, what you have to know is that the general equation or the equation of the line that we just got, that is here. Y is equal to 4 on 3x plus 10 on 3. So that's the equation of the line. Now, we are saying that we should find the x-intercept. And I've just illustrated for you that on the s-intercept, y is equal to 0. So finding the x-intercept means we're going to put y to be 0. I hope you understand what I'm talking about. So on the x-intercept, y is equal to, 0 on the x-intercept. So if y is equal to 0 on the x-intercept, then using this equation, wherever we see y, we just have to put 0. So I'm going to get, 0 equal to 4 on 3x plus, 10 on 3. So what do? We are going to find the value of x. So we can just multiply through by, the LCM, which is 3. So I'm going to get 3 times 0 equal to 3 times 4 on 3x plus 3 times 10 on 3. So this is what I'm going to get. 3 times 0 is going to be 0 equal to this one. I'll just cancel this one. So we have 4x left. That is here. Now, plus 3 also cancel this 3. We have 10 left. So what do we do next? We just have to take this 10 to this side. So that's going to be negative 10 equal to 4x. I'll divide here by 4, here 2 by 4. So this 4 cancel this 4. So this implies that x is equal to negative 10 on 4, which we can still simplify this one. So x is equal to, 2 here, 2 here, 5. So you're going to get negative 5 on 2. So that's the x-intercept. So the idea is that if they ask you to find the x-intercept, just put y equal to 0. Do your substitution using the equation of the line. Find the value of x. So now that we are going to solve the last one, which is the y-intercept, we are going to put x equal to 0. Because whenever you're on the y-axis, x is equal to 0. That is something that you're supposed to know. So let's get the last one here. So the last one is going to be question 1a v, and we have to find the y-intercept. Now we are still using the same, equation of the line. So that's going to be y equal to 4 on 3x plus 10 on 3. So that's the equation of the line. Now we have to find the y-intercept. Remember, finding the y-intercept means x is equal to 0. So that's what I'm supposed to know. So x is equal to 0 on the y-intercept. So that means that wherever we see x, we're going to put 0. So this will imply that y is equal to 4 on 3 times 0, because x is here, plus 10 on 3. So y is equal to anything times 0 is going to be 0. So this, this part will vanish or disappear. Now plus 10 on 3. So that is the y-intercept. So that's the basic idea that we use to find the x-intercept and the y-intercept. Let's come to the next question. So let's get the question 1b solved here. And that's a word problem. That's the question. Twice a number added to 5 is half the same number subtracted from 2/3 of the number. Find the number. So before we solve it, we have to define, the variable that we're going to use in place of the number that we don't know. Yeah, because we are looking for a certain number that we don't know. That's the unknown. So you can use a letter for that. So you can just see, let me write the question number. That's question 1b. So let x equal to the number. Now that we know this one, let's go back to the question. Twice a number. Now we know that the number is x. So that's going to be, twice means 2 times the number. So that's going to be 2x. Now added to 5. That means plus 5. Is, the word is here. Is. This is a keyword that you're supposed to know. It's a connector. So twice a number added to 5 is half. So this is here means equal to half the number subtracted from 2/3 of the number. So the question could have been this: twice a number is equal, added to 5 is equal to half the same number. But here, we didn't bring equal to, we just wrote is. So you should know that the is here means equal to. So let me get to the next part. So you're going to get this, the next part here, which is half the same number subtracted from 2/3 the number. Now, half the same number means half times x. That is half x. And we're going to subtract this one from 2/3 the number. 2/3 the number means 2 out of 3 x. So we're going to subtract this one from this. That is what the question or the statement is trying to, say here. So I'm going to get 2 out of 3 x minus 1 out of 2 x. So that is what we mean by half the number subtracted from 2/3 the number. That is it. So from this point, we have an equation. So you can use the basic idea you have on, equations to simplify or to find the value of x. So here we have to find the LCM, and the LCM is obviously going to be, 6. That is the LCM for 3 and 2. So we multiply through by the LCM, we're going to get 2x times, 6 plus 5 times 6 equal to 6 times 2 on 3x minus 6 times 1 on 2x. So that is what we have. So at this point, we can do cancellations and also simplify. So we can see that 3 goes into ACF1, it goes into 6, 2 times. In 2 here, 1. 2 here, 1. It goes into 6, 3 times. So now let's do the multiplication. So 2x times 6, that's going to be 12x. So you have 12x here. And now plus 5 times 6 is going to be 30. So you have 30 here equal to 2 times 2x is going to be 4x. And now minus 3 times x is going to be, 3x. So this is what we have. We have been able to, do away with the fraction or eliminate the fraction. So at this point, we can still simplify. We have 12x plus 30 equal to 4x minus 3x is going to be x. So that's what we have. Now, to find the value of x, what do? We have to take this x to this side, then we'll bring the 30 to this side. So that's going to be 12x minus x equal to negative 30 because I brought this one here. So this one will give me 11x. That will be for 12x minus x equal to negative 30 here. Divide here by 11, here to by 11. So we will have with x equal to negative 30 out of 11. So that's the answer. If you want to change to mixed fraction, you can go ahead and do that. So that's the final answer for that one. Question 1c. And this is the question. Find the value of z if this is greater than this by 5. Oh yeah. So, the whole of this expression is greater than this one by 5. So what do we mean by that? That means that this expression minus this should give me 5. So, 5 is greater than, let's say, 2 by 3. That means 5 minus 2 is going to be 3. So that's the idea that I'm going to use here. So let's get it right now here. So it's going to be 3z minus 2 on 5 minus 1 minus 4z on 10, and that should give me 5. So that's the interpretation of this, statement. So at this point, we have an equation which we have to, solve by multiplying through by the LCM, and the LCM is going to be 10. So we have 10 multiplying. You should remember that the numerator here is a binomial, so it should be kept in bracket. We have bracket of 3z minus 2 out over 5 minus the same thing applies to this one, another binomial. So you have 10, times 1 minus 4z out over 10 equal to 5 times 10. So at this point, we have to do cancellations. So 5 here 1, 5 here 2, 10 here 1, 10 here 1. So now we have 2 multiplying, 3z minus 2 minus, we have 1 multiplying 1 minus 4z equal to 5 times 10 is going to be 50. So let's expand the bracket to remove them. 2 times 3z is going to be 6z. Now 2 times minus 2, I've even said the answer. So that's going to be minus 4. Now here you have to be very, very careful. That's why I brought the 1 here. Now you should know that this is not 1, but rather negative 1. So that's going to be negative 1 times 1. That will give me neg 1. Negative 1 times negative 4z will give me positive 4z equal to 50. So this is what we have. We can simplify, then we find the value of z. So on the left hand side, we have this, we can simplify. So let me continue from this side. We have 6z, I'm grouping like terms, plus 4z. Now, minus 4 minus 1 equal to 50. I hope you are not confused. So 6z and this one, they are like terms and they have been grouped. This is minus 4 and that they have also been grouped here. So 6z plus 4z, that's going to be 10z. Now minus 5 equal to 50. That is minus 4 minus 1 will give you, negative 5. So we can just take this one to this side so that we get 10z equal to 50 plus 5. So you have 10z equal to 55. We divide here by 10, here too by 10. So the 10 will cancel this 10. We have z equal to, 55 out of 10. We can use 5 to simplify. So 5 here is going to be 2. 5 here is 11. So we have 11 on 2, which can be written in mixed fraction as, 5 whole number 1 on 2. So that is it. That is how we can find the value of z. Let's get the last question, which is about vectors. So that is going to be question 1di. Now these are the vectors. The vector p, that has components 2, 5. And the vector q also has components, 8, 6. And we have to find I, that is p plus q. So let me just do the substitution here. This is very, very simple. So p is, 2, 5. I just have to replace with this now plus q, and q is 8, 6. Now I can add the corresponding components. So that's going to be 2 plus 8 and 5 plus 6. So easily we are going to get 10, 11. So that's the answer. Okay, so let's get the last question here. So that's going to be, the question 1dii. So we have that one here, 1dii. And the expression is 2p minus q. So we have to get, the vectors here. We just have to do substitutions and we simplify. But remember that in this one we have to multiply in the vector p. So that's going to be 2 multiplying the vector p, which has component 2, 5, minus, there is no scalar multiplying the vector q, and the vector q is 8, 6. So we have, 2 times 2, that's going to be 4, and 2 times 5, that is 10, minus 8, 6. So at this point, we just have to subtract corresponding components. So we have 4 minus 8, that will be for the x component, and the y component, we have 10 minus 6. So we are going to get minus 4, 4. So that is the answer.